Okay, guys, we have dealt with 4.1, right? And then we got our answer to be sine theta over cos theta, which was just the same as saying tan theta, right? So this was fine. And then that's how you get your 4 marks. But let me just go through the memo with you, the first part of it, of 4.1. Yeah, so this is what they did. So, like I said, guys, you get a mark for writing your left-hand side. And then they're gonna mark you for taking out a common factor. So they took out sine theta there. Then they were left with 1 minus cos theta, which is good. And then they said that, okay, then they're like, okay, then they changed 1 minus sine squared theta because they knew that it's an identity. So they changed it to cos squared theta, right? Then they had take out cos theta in the denominator. Then they had 1 minus cos theta. Hence, this two then divided into each other. Then they had tan theta, and that's where you score your full 4 marks in this case here. So yeah, this is your memo, and let's go back to the first. Let's go back to now. Let's go back to the identities part, right? Which is this one here. Okay. So now with identities, nah, so the whole purpose of identities is to make sure that you have a single trig ratio. Like, the whole purpose is to break it down in such a way you have a single trig ratio. You know what I mean by single trig ratio is like you can have like a coefficient of 1. Basically you're gonna have a coefficient of 1. Like, nothing should be affecting the trig ratio. There shouldn't be like a 2 here. Like, no, we don't want to see this. We want to see a trig, like a single trig ratio. Like, the whole purpose is to see a single trig ratio which is equal to maybe something. Maybe, for example, tan theta is equal to 3 over 4, and this is gonna be a single trig ratio. So that's what we do with general solutions. So we want to make sure that we have a single trig ratio. So now here we're gonna break this down in such a way that we only have a single trig ratio. So most people will consider actually transposing the cos squared theta that side, and then maybe they'll wanna divide by cos cos x, because they can see that sine x is multiplying with cos x, right? And honestly, you can do that. There's so many ways you can prove what's this, you can approach general solutions, but I'm gonna work with the one that's more comfortable with me. And from here, what I can do is I can see that we have a 2 sine x cos x minus cos squared x, but then I know that I have two terms here, right? This is the first, that's the second term, and both of them have cos x. So let me try to take out cos x as my common factor, and let's see where that leads me. Nah? Okay, let me switch the pages here. Okay, so I'm back here, nah? Okay, so now let me take out cos x and let's see, because the whole purpose is for us to remain with a single trig ratio. Remember that, guys. If you don't have a single trig ratio, you cannot determine the general solution. So let's see cos x, right? And then let's take this here. So this is gonna multiply with 2 sine x, right? Yeah. So we know that it's still the same thing that's gonna happen, right? Minus. So I know that, okay, from here we're gonna have cos squared x and cos x. So this is just going to be cos what now? Cos x, right? Which so I think we've factorized. Yeah, so we can factorize fully. Sometimes you must check to see if you can factorize fully. Like, the last thing you want to do is even transpose. That's one thing I can tell you. The last thing you want to do is transpose. The last thing you want to do is to transpose. So from here, you just factorize and see where it's gonna take you, nah? And then let's say that, so now you have cos x into 2 sine x minus cos x, right? And then this is basically equated to 0. Oh, I don't even have space that side. I don't even have space that side there, but I'm just gonna write it here. I'm just going to write it here now. Let me just write it again. I'll just write it here. Cos x into 2 sine x minus cos x is equals to 0. Yeah. Then from here, what do we do now? Okay, now from here, now we can see now there's multiplication, and we know that whenever there's multiplication, either of them can be equals to 0. It's like saying either of them could be equals to 0, so I can equate them to 0 because there's multiplication. Like, just the same way how you do in algebra when you'd have like x plus 1, for example, x minus 4, cos 0. Then you solve for x in that sense, right? So it's the same thing that happens here. So I'm just gonna say cos x is equals to 0, or 2 sine x minus cos x is equals to 0, right? Okay, now can you see that here we have a single trig ratio here now? This is a single trig ratio because this cos x equals to 0, but here it's not simplified fully, so we have to break this down. But if you look at sine x and cos x, it reminds us of something, also an identity again. So you also apply identities here. So it reminds you of tan x. So imagine if we had 2 sine x, right? And let's transpose the cos x to the other side. So this becomes cos x. And then let's try to make tan x here. So how would we make tan x? So we could just divide. So to make tan x, we know that tan x is the same as saying sine x. So if you have sine x over cos x, it's just the same as saying tan x, right? So I would divide by cos x here. You're allowed to do that, guys. You're allowed to do that. The whole purpose is to find a single trig ratio. So basically, so when cos x divides into cos x, you're gonna be left with 1, right? And then when you're left with 1, so 2 sine x cos x would just be 2. So this becomes what now? 2 tan x. So this becomes 2 tan x equals 2. So cos x over cos x is equals to 1. Then what can we do here now? We want to make it a single trig ratio. So what's disturbing us is this 2 that's multiplying. So I'm going to divide both sides by what now? 2. Then this and this will divide into each other because there's multiplication taking place. Né? You agree? Then from there we're going to have what now? We're going to have tan is it tan x that I have there? Yeah, it's tan x. Okay, so we're gonna have tan x, right? It equals to 1 over 2. Yeah. So from here now we have two trig. We have now two what's the single trig ratios, ne? So the first one was cos x, ne, equals to 0. Let me just write it down. Here. The first one that we had. You can just go back, ne, just to see where I got it from. But I'm just gonna write it down here. Let me write it down for you. So the first one was that we found that cos x is equals to 0, or tan x, right, is equals to 1 over 2. Yeah. Now from here you can determine the general solution. So sometimes you might have two solutions, sometimes you may have one. It really just depends, because remember I said the last thing you want to do is transpose. So try to find ways. Maybe you can factorize first. If it doesn't work, then you can transpose. Then maybe you can form a tan theta. You just never know. Then from here, you're gonna find the value of x. So we just refer to this as our reference angle for now, because we know that they behave differently in the quadrants. So I'm just gonna let x be the reference angle for now. So I'm gonna say reference angle is equals to cos arc 0, right? So this is going to be reference angle is equals to, so you can do them separately and always look at, so this is 90 degrees, right? This is 90 degrees, so this gives us 90 degrees. Okay, and every time we get our reference angle to be 90 degrees, basically what happens is that so we take the period of the cos graph. So the period of a cos graph is 360 degrees, right? And the period of a tan graph is 180. So we're gonna still keep those in mind, right? But then we're going to ask ourselves, so this trig ratio here is positive here. So we're gonna ask ourselves, in which quadrant is cos positive? So we know that if I had a quadrant like this here, né? We know that all trig ratios here are positive here, but sine here is what now? Sine theta is negative. Sine theta is also positive here, but all the other trig ratios, the cos theta, tan theta, they're all negative here. And here we know that tan theta here is positive, and all the other trig ratios here are negative. And also here cos theta is also negative here. But we know that cos theta here is actually positive, and then all the rest of the trig ratios are negative. So negative tan theta would be here, negative sine theta would also be right there. So now we know that cos theta is so we know that we're dealing with a positive trig. We're dealing with a positive trig ratio, né? Yeah, a single trig ratio. So we know that cos is positive in the first quadrant and also in the fourth quadrant. But then you must also ask yourself that if they are actually positive there, what happens in those quadrants? So what happens in those quadrants is this. So you need to remember also that they represent them with the reductions. You should remember reductions. So this is where reductions comes in. So here is the same as saying 360 degrees plus theta, ne? And in the second quadrant it's 180 degrees minus theta. In the third quadrant it's 180 degrees plus theta, and in the fourth quadrant it's 360 degrees minus theta, ne? Yeah. So, or you could even say 90 degrees plus theta. No, not 90 degrees. 90 degrees minus theta. Sorry, 90 degrees minus theta. It's not a problem. It's still in the first quadrant. It's still in the first quadrant. You can still say 90 degrees minus theta. So people use it in two ways, but it's honestly it's fine. There's no problem. Then from here, so theta is going to, so this theta is going to represent our reference angle. So this is the angle we're going to use to subtract now. We're going to subtract. So we say that cos theta is positive in the first quadrant, right? Okay. Now let's do this now. Let's do this. But when your angle is, so the whole purpose, right, is that you're always going to, when you solve for your angle, it's always going to be an acute angle, né? And this acute angle is going to exist in the first quadrant, because in the first quadrant we know it's between so in the first quadrant, yeah, let me just remind you guys that in the first quadrant it's 0 degrees, and then when you move up towards this, so it's going to be 0 degrees there in the x-axis, and then basically, oh wait, yeah, 0 degrees to 90, right? Yeah, in the first quadrant 0 degrees to 90, and then from there we know that, okay, so it's going to be positive in the first quadrant and in the fourth quadrant. So we know that, so it's 90 degrees basically, so it's just going to remain as 90 degrees plus 360 degrees times k, where k is an element of integers. So you could also still say that 180 degrees, because normally they say that if you get an angle that's 90, the period will change to 180. You can change it to 180 or 360. Honestly, it's really it's fine. There's no problem. You can do that. But also this works. So we know that it's 90 degrees is an acute angle, and acute angle is between 0 to 90. So in the first quadrant, this is going to be the general formula. And then where else does it exist? It also exists in the fourth quadrant, nah? Okay, so we're gonna also do the same in the fourth quadrant. So in the fourth quadrant, we're gonna have, so what's the reduction? So we know that it's the reference angle. So the reference angle that we got, oh, I never did let me do it. So it was tan theta, right? It was tan theta equals to 1 over 2, ne? Yeah, so theta is going to equals to tan arc 1 over 2, which means that our theta is going to be tan arc 1 over 2, which is going to be 26.57 degrees, nah? Oh, let me just represent this as the reference angle, because we're not sure as to which, if this is the actual angle, because we're following the reduction, nah? Okay. Oh no, what am I doing? Wait, I did the first part of the, I didn't do the second quadrant, eh? Yeah, I mean, I didn't do the fourth quadrant of this one. So let me do the fourth quadrant. So we know that the, what's the reduction in the fourth quadrant? It's, okay, yeah, so I actually missed the fourth quadrant. Yeah, so we're gonna, so we know that the angle, the reference angle there is is 90 degrees, né? So when I say 360 degrees, or let me just go down and write it down at the bottom. Let me write it at the bottom. So it's going to be, yeah, so 360 degrees minus reference angle, né? So this becomes 360 degrees minus 90 degrees plus 360 degrees times k, where k is an element of integers. So that's basically telling you that if you multiply by any integer, it's always gonna give you that trig ratio tan 1/2, né? Yeah, so 360 minus 90 gives us let me just take my calculator. So it's 270. So that means that this is going to be 270 degrees plus 360 degrees times k, where k is an element of integers. And these are the general solutions for the cos theta part, because you know that cos x, cos x is positive in these quadrants. The fourth quadrant, it's positive in the fourth quadrant and also in the first quadrant. So these are your answers, right? 90 degrees plus 360 and 270 plus 360. And then remember, we're not done. We still have to do tan x. So tan x was equals to 1/2. So we're gonna say, so what was the angle? I think we did it earlier on, né? Yeah, we did. Let me just double check. Let me just double check what it was. I don't know. Let me just double check. Oh yeah, so I actually didn't do it. Yeah, so let me just fix that. So this is going to be so the reference angle there. So it's going to be the reference angle is equals to tan arc 1/2. Okay. And then so this is going to be basically, it's going to be reference angle is going to equal to tan arc 1/2, which is 26.57 degrees. Yeah, then we know that our trig ratio here, it's positive. So we know that our trig ratio here is a positive, so we ask ourselves, where is tan positive? So tan is positive in the first and third quadrant, eh? So I'm just going to do the first. So it's just going to remain as it is, because 26 degrees is actually an acute angle. So in the first quadrant, it's just going to be 26.57, right? 57 degrees plus, but the period will change. We take the period of a tan graph, plus 180 degrees times k, where k is an element of integers, and then that's the mark you get. This is 6 marks also, so that's where you get your mark there. And also it's also positive in the third quadrant. It's also positive in the third quadrant, right? So it's also positive in the third quadrant. So in the third quadrant, you're gonna have, so what's the reduction there? It's going to be 180 degrees plus the reference angle, right? Plus the reference angle. So it's going to be equals to 180 degrees plus 26.57 degrees plus 360 times k. So this is going to be 180 plus 26.57, which gives you 206.57 degrees times k, plus 360 degrees times k, where k is an element of integers. K is an element of integers. Yeah, then that's all you do. So basically, make sure that you have a single trig ratio. That's the whole purpose. Make sure you have a single trig ratio. Then after having a single trig ratio, if your trig ratio was negative, you're just going to ask yourself, okay, where is cos negative? So cos is negative in the second and third quadrant. Then that's where you're going to work in. Then you just apply the reduction that takes place in the second and third quadrant. Then if tan x was negative, so you're going to say that, okay, tan x is negative in the second and fourth quadrant. So I'm just going to take its reduction and then just make my general solution. And then you can always test. So you can always say 206 degrees 0.57 degrees plus 360 degrees times any integer. So if I take like 206, right, 0.57 degrees, right, plus 360 degrees, right, times k, so I can say I can multiply it by 2, ne? Yes, so when I multiply this by 2, and then let's say I get like 206.57, right, plus 360 times by times 2, ne? It gives me like 926.57 degrees. So when I say like tan 926.57 degrees, it should get me to 1 over 2. So let's say tan 926.57 gets me to 0. So it gets me to 0.5, which is just the same as saying 1 over 2. 1 over 2 is just the same as saying 0.5. So you can always check to see if it makes sense. So yeah, and it makes sense. So that means it's going to exist. So I already do it here, né? Oh yeah. So yeah. I'm gonna share the memo now with you guys, then you can just check your solutions. Okay, thank you.